Okay, so this is a continuation of the last video. So more likely this core here is this chart here. We look at here, we get like 16, which is in green. Click here, we get 16 millitesla. And this one here, if we look at this green here, click here, we get 4 millitesla, 4.7 millitesla. So this one here represent this core, and the secondary core, secondary foils is this chart here. So if I click on the purplish, should be around 1 point something. Top here will be like really low, right? And we click by the yellow, we will see like 5.2, which is like here. Okay, so if we look at this next one here now, we'll be looking at this one here, right? So this is 1.9. So 1.9 will be around here. We look at around 4.5. We click around here, we can see around 4.5, right? And going on to south, which is this one here, we click by the green here, we will see 34, which is around 34 here. So this is the chart. I will do a photo of this and put this over here and put some proper label in what scale belongs to which area and the orientation here. So this is that, and we just bring in this one now. This is the cross section, right? And the cross section now, you can click and look at the, when you have one bar here for everything. So this will be 12, around green is 12, the green here, right? And blue could be 10 itself coming down. Red will be 34 coming up to around 34 around here. So we have heavy current magnetic density in the corner here, right? So, and we could look at the foil internally too as well, right? So the cross section, we could see those guys here, right? Right before I move across to the next one, we can look at, we could go straight back and you can see we're going to 0 time and right, and 0 time. This one is do first and then this one take a while to do, right? And when it says 0 time, it's like 0 point so on so on so on, but we just need to have one digit over here. So if we go next, this is our step time, 1.0571. That's our step time. So we can actually see, the current density changing in time. Go next step. Go next step. I just want to take out time, and we can measure the value itself, right? It's take a while to read because the data, you have to have, like, if you have a NAS drive or some server with storage SSD, and you click and you run this out of server, it will run really fast. I will do this for web page version 2 as well, so when I start running this on my server, it will not have this thing. But this right now is a standalone that actually compiled for Linux, Mac, for some silicon processor, and I think, let me just pull it here. So this is for Windows, this one for Linux, this one here is for the silicon Mac, this one over here is for ARM processor Linux, and this is Intel Mac, right? So I will be rebooting from Windows going into Linux to test Linux version 1, right? So when I'm going to compile another version to this, and when I finalize everything, we have reports and everything else to do, this is a test. I will be doing it for a web page, so we're gonna run out a server So yeah, so we could pretty much go through things, and I'm going to close these two guys. We done been through that, and kind of like, so this is the temperature now, right? Yeah, now scroll through this. This is basically, if you're like the 100 microseconds, this is the point in time we want to see after all the workage that happened. What is the heat buildup on this, right? So the corner, we notice the corner, and this is the same thing. We just pretty much have to consider the same scale factor. This core belongs to this foil belongs to this one, and this core, this one, and this foil is this one, right? So when we click here, we can see the value. We can see we have more heat inside, right? So these heat itself, the heat that taking place here is because the magnetic field penetrating from the inside first, right? So right, so we have a transparency. So I run a transparency so we could see the inside a little bit, right? And I'm not sure if I had to put any cutaway section. This is what? Rotate. Projection. Okay, a projection have it looking retarded. Anyway, and this is what? Okay, we have different settings itself. I really don't care about that. But anyway, right, so take out the light and see. Yeah, we have light reflection, we see the inside more vibrant, I guess, but kind of like casting shadow the light. So we can see the magnetic density inside is happening a lot. We just remove this, put back the light, right? So we can see, but when we change it, we see a different coloration. So it kind of misleading when we go different angles. So I remove the light itself, so the colors will remain the same. So click over here, right, and the scaling for this is right. What's a meter cube, right? So minus something. So not that bad in that sense. It really not bad because it minus 6, right? 0.2. So this kind of pretty much good, but you know, after running, after time, temperature has built up itself, and if you run a simulation long enough, like really long, and this is just microseconds, if you run it into to hours, whatever the case might be, temperature does build up. So you know, these things build up. So I guess that if you have a supercomputer, a nice server, we can run this for really long and come back at it. You can look at the temperature itself. So and you could pretty much, if you run different time range, you can make approximation, and you know, when you design a heatsink for this, you could, you know, just write a design a heatsink to cool, and you look at all those things. So I guess this is it here, and yeah. So now, if I want to reset, right, if I want to reset my values, I just come and hit reset value, and it will reset all the value here, right? And if you want to save, you save before, like save as, and you have the data save and thing. But you know, later I got work on this and create everything. So okay, so exiting. So anyway, this is the end of this, and thanks for your patience. You could just, should I say this before, but I hope you skimmed through because it's a lot. Until next update.